Okay, for a lot of these problems, you won't have your triangle drawn for you. So when you're given these A, B's, and C's, keep in mind capital letters always mean angles, lowercase letters are sides, and then when you have corresponding letters, those are opposite each other. So if we draw this triangle, we have A, B, and C. So we know A is 32 degrees, and then this side A is going to be the side opposite angle A. So that's where we have our 42.9, and angle B is 81.8 degrees. So law of sines very much works in opposites with each other. So what it says is if we have A over sine A, that equals B over sine B, which equals C over sine C, or vice versa. It doesn't matter which you have on top or bottom here as long as it's consistent. So you don't use this triple equation at once, you just pick a pair to use. So like in this case, we have our A's and B's. So we're just going to use this A over sine A equals B over sine B, part of the equation. And now we'll just plug in what we have. So what we're going to solve for first right now is side B. Like I said, law of sines works in opposites. So we have our one full opposite pair of A's. That means we can solve for our other opposite. So we will plug in 42.9 over sine of 32, and that equals B over sine of 81.8. Now we have a proportion, and we just cross multiply, divide. So first we cross multiply, get 42.9 sine of 81.8 equals B times sine of 32. Now again, we're solving for B, which is this piece right here. Remember, sine of 32 is just a number, and we have B times sine of 32 right now. So to isolate B, divide both sides by sine of 32. Now you just use your calculator, type in this whole piece, and that is your answer. And go ahead and practice that now to make sure that you're using your calculator right. But in this case, you should get B equals 80.1. We'll just stick with one decimal, 0.1. So now when you're told to solve a triangle, that means to find all the missing sides and angles. So in this case, we have 80.1 for B. We still need angle C and side C. So first, the easiest piece to find is angle C, because we already have two of the angles. So we know the angles of a triangle add up to 180. So we do 180 minus 32 minus 81.8. And we get that C is 66.2 degrees. Now we can go back, use law of sines again. So we'll do 42.9 A over sine of A is equal to C over sine of C. Again, same as before, cross multiply, divide. So we end up with sine of 32 times C equals 42.9 sine of 66.2 divide by sine of 32. Type that whole thing in your calculator and you get C equals 74.07, so 0.1. So for these problems, you'll always be given 3-point pieces of information, and you're going to need to be solving for the other 3 pieces of information. Keep in mind, these are now oblique triangles. We do not have right triangles. So once you get 2 sides, you cannot use the Pythagorean theorem. That is gone. Can't use that anymore. You can still use it. The angles add up to 180. That's true for all triangles. Pythagorean theorem is not. So now that case you just saw was when you're given 2 angles in the side opposite one of those angles. And we're going to talk more about this tomorrow. But this essentially is an example of when you are given angle, angle, side in a triangle. And just keep that in mind, because tomorrow we're going to talk about all these scenarios. This next problem is an example of when we are given angle, side, angle in a triangle and how to use law of sines there. So first we're going to draw our triangle out. Again, don't worry about it being exact or really to scale at all. Just label it the way it says. So we have A is 87.2 degrees. B is across from angle B, so 75.9. C is 74.3 degrees. So now, remember what I said before, where law of sines is all about having an opposite pair. In this case, we don't have an opposite pair yet. However, we have two angles, which means that third angle is really easy to find. So first step in this angle side angle case, and again, we'll talk more about that tomorrow, is to solve for your third angle. So we subtract those from 180 and we get that B is 18.5 degrees. Now we can set up our law of sines because we have a full side, and we can use B over sine of B. It doesn't matter which we solve for first. I'll go ahead and solve for A first. So we'll plug into this formula. I'm going to bring it up top here so I have more room. So we do 75.9 over sine of 18.5 degrees equals A. That's what we're solving for. Over sine of A, and A is 87.2 degrees. So now, just like before, just a quick cross multiply, divide. So A is going to be 75.9 times sine of 87.2 degrees, all divided by 18.5 degrees. Plug that into your calculator and you get 238.9. So there's side A. And that may seem like a big number, but if you reason with this, angle B was only 18.5 degrees, so really small angle. The side opposite was 75.9. Therefore, the side opposite at 87.2 degrees, about 5 times the measure, is going to be a lot bigger than that 75.9. So you can always look back at the triangle and reason smallest angle should be opposite smallest side, and so forth. So now we just need to solve for side C really quick. We can start with the same ratio, B over sine of B. And this is going to equal C over sine of C. Again, cross multiply, divide, and we have 75.9 sine of 74.3. Divide out the sine 8.5, type it in your calculator, and you get to 30.3. So just like before, you were given 3 pieces of information, you were solving for the 3 missing pieces of information. Overall, this formula should be a pretty simple formula for you. So I'll have to set up your proportion, use a calculator. So now on the next slide, go ahead and try completely solving those 2 triangles.